Hello and welcome to today's Technical Corner. Today joining me is Ian from the threading experts at DC Swiss UK. And this is a little bit different. We'll move on to the Nano stuff a bit later on. But let's talk about thread milling in particular.
Yeah, again, solid carbide this time, round tools from DC. We want to talk about the traditional thread milling cutters. We also want to talk about thread whirlers and the differences that we basically describe. So a thread mill tool is there with a number of ribs, and the number of ribs are longer or at least as long as the thread length that the customer wants to actually achieve. So the customer will come to the centre of the hole, drop into his full thread depth, arc onto cut, make a 360 degree movement or a little bit more maybe, and then arc out of cut and the thread is finished. The thread whirler is more like a single point tool. Okay, you can drop to the bottom of the hole making a single point interpolation all the way to the top, or you can work from the top down.
Sure, what are the advantages over, say, a thread whirler than a thread milling tool?
Okay, thread milling can be quicker, or is quicker in applications where it's the most appropriate. You can also spread the wear of the cutting process over more ribs or lobes of the actual tool. So because the whirling tool is a single point act, you've actually got more wear on the cutter. So the thread mill can be quicker and less wear.
Sure, I guess the same question, but the other way around, if you know what I mean.
Right, okay. There's numerous benefits to thread whirling. Particularly the two critical ones are one for very small holes, okay, and one for very deep holes. You've got less contact. So with less contact becomes less problematic for deflection. So in that case, radial pressure is very difficult for small threads, and for deep holes, obviously, less contact, you can get 4 times D.
And the viewers watching, it won't be surprised for me to say you've got a massive range of thread whirlers, thread milling, call them thread milling tools, I think you know what I mean.
Yeah.
So just quickly run through the range for me.
Okay, first of all on the thread mills, all DIN standard, okay, DIN standard shapes. So that's recognised throughout the European base of quality manufacturers. And the benefit to the customer on that, of course, is obviously he can take one of those standard forms, take out the opposition tool and try a test without really changing too much. The outside shape of the tool is determined by the DIN norm. And what you would expect from DC is a full range there. So you've got GF, GFS, which is the countersinking, counterboring tool, GFM, which is the neck tool, so you can get a little bit deeper, and you've also got BGF, which is the drill thread mill. So that's the thread mill range. On the thread whirlers, we've actually got 5 series. We're talking about thousands of options here, thousands of tools actually. And so 5 series. Series 1, would you believe we actually produce our smallest thread standard with a thread whirler? Not a tap, it's actually with a thread whirling tool. That series 1 is single rib, single flute, so it's the original single pointed tool. Series 2 is single rib but multi-fluted, so you can actually generate a pitch with that, okay, because you've got one lobe and you can move wherever you want under your numerical control of the machine. Series 3 is the widest possible range in our range of tools, so you've got lots and lots of thread sizes in Series 3, and this is the most popular by some distance. Dedicated in size, twin ribbed, so there's 2 ribs, dedicated on pitch, multi-fluted. You've got options at 2.5 times D, 3 times D, 4 times D, with integral coolant, without integral coolant, solid, 2 coating variations, the list goes on and on. We then jump from Series 3 to Series 5, and Series 5 is also known as the perfect thread, okay? And it is exactly that. That's basically, that tool will deburr the whole of the thread form, not just the core hole. Okay? So this is very pertinent to medical industries, anything that's going inside the body that has to be burr-free, also military. And as I say, we don't just trim the core hole with the tool at the simultaneous time that we're thread milling, but we actually produce a deburr thread across the whole form, which is unique.
Sure.
Okay.
How long have you been producing these tools? The whirlers, I mean, or the whirling tools?
Yeah, thread milling has been around maybe for maybe kind of the early 90s, I suppose. But thread mills, single point tools, I suppose, have been around a long time, but they've come back into vogue because of the benefits that they've given us. And the range, when it originally was came out, because of the benefits on small sizes, went from M08 up to M6 only.
Sure.
Okay, we're now up to M20. Okay, because there's lots of demands for deep holes these days. Deep holes in exotic materials.
Sure.
Thread milling, safety, security of process is critical, and that's where the big benefit is. It's got a better thread depth range than a tap, even, because particularly on blind holes, controlling that chip with a tap is very, very difficult over 3 times D, and there we have a solution.
Just finally, and apologies in advance to the cameraman, we've got not micro, we've got nano micro end mills here, and trust me, there is a thread on the end of there. So just briefly talk us through these, please.
Yeah, this program of tools is clearly, it's not just close, it's clearly the best in the world. Okay, their program of micro tools DC Swiss produce is just phenomenal. So the smallest thread that we produce as a standard is M0.3. So that's 300 micron diameter.
You wouldn't want to put it in the wrong box because you wouldn't know, would you?
No, difficulty getting it out of the box in the first place. And that is with an 80 micron pitch.
Good grief.
So it's it's seriously small, and it's a seriously good series of tools. We're talking about taps as well in that format. So there's starting at metric 0.3 in taps and in thread whirlers, all the way to 2.76 because of the imperial. Who on earth is buying
those in? Obviously, I'm guessing medical, watchmaker, maybe electronics, phones, things like this.
Yeah, driven, I think, initially by watchmaking, where there is plenty of exotic materials these days as well. The Swiss market is what drove that initially, and DC made a big commitment to gauging as well in that. They're actually not just producing the gauges, they're actually doing a lot of the gauging process for the customer themselves.
Sure.
And they produce not just go gauges and no-go gauges, but wear gauges as well. And they follow the same format, so M0.3 to 2.76.
So some of the viewers may know I'm from a threading background. I used to produce threading tools. Do you know what? I wouldn't know where to start with that. I guess it's the machines, isn't it? It's the machines. But what this is showing, again, DC Swiss, threading experts, pushing that boundaries just that little bit further.
Yeah, capability of staff, capability. It's not just producing it; it's checking them as well.
Yeah.
It's the whole gambit, and the level of capability and expertise that we're talking about within our factory is just exceptional. So I wonder at what we actually produce and what we're capable of producing, certainly at these type of sizes, and they just keep pushing the boundaries.
Yeah.
It's across the range. It doesn't really matter whether we're talking the tiniest tools to the largest tools. What we would like to do is say to our customer base and the people who are not dealing with us at the moment is, can we improve? How would what are you going to put in front of us so that we can be challenged next? Okay, and if you've got a relatively free cutting application at the moment that you would like to challenge us against your current supplier, then we're up for that, and we'd like to have a go and see what we can do for you.
There we have it. Ian has set the challenge. So you people, you engineers out there with a threading issue, maybe you haven't got a threading issue, but you can still improve your process. Give the team up at DC Swiss UK a try. Thanks for watching.